Okay, I've pushed the record button. My watch says the equivalent of 21Z. So we're going to start with today's FDTD Satellite Applications webinar. We're very happy today to have Brandon Idlett, who is the lead meteorologist in the forecast office where the National Weather Service Day begins. So you notice it says it's January 20th, 2022, because in Guam right now it's 7 a.m. So Brandon will be giving this talk with Nick Slaughter, who is a meteorologist in Guam. Take it away.
All right. So good morning, Scott and everybody. Again, thank you so much for having us join you in for this. We're happy to talk about NUCAPS and how we kind of incorporate it in our operations out here across the tropical Western Pacific. So without any further ado, let me just go ahead and give a quick recap of NUCAPS, and just to kind of freshen everybody's memories. So NUCAPS stands for the NOAA Unique Combined Atmospheric Processing System. NUCAPS data are generated from polar orbiting satellites. It's a combination of information from the CRISP, the Cross-Track Infrared Sounder, and the ATMS, Advanced Technology Microwave Sounder, to give you a nice atmospheric profiles. And then later on, you can see that these profiles of data and these layers can be combined to give what is called gridded NUCAPS data, which may be actually very helpful for seeing trends and gradients, at least in a two-dimensional map view. Availability is roughly in the mid-afternoon and then in the hours after local midnight. So you're going to see a couple passes during the day. And of course, for this CONUS and Alaska region, there's actually some more data that you receive from the additional satellites, and I'll tell you about that a little bit later on. I know Scott through CIMSS has some training modules available that kind of talks about the other satellites that provide NUCAPS availability. And so region to region is a little bit different, whether the data comes through the SBN or direct broadcast. So check in with your local SUS or even your local regional headquarters for more information. So how about the good versus bad NUCAPS data? Well, like I mentioned just the slide before, NUCAPS data is a combination of infrared and microwave retrievals. So there are some potential points of failure. The infrared data can be see some bad retrievals depending on uniform cloud cover. And then areas with precipitation actually start seeing some issues with the microwave retrievals. So the quality of the data is very easily displayed, whether you're looking at it on AWIPS or through the internet. Red, yellow, green. Green data indicates good IR and microwave retrievals. Yellow indicates that problematic IR retrievals. And again, this is likely due to clouds and more of a uniform cloud cover. And then the red data indicates bad IR and microwave retrievals due to rainfall. But the other thing to keep in mind with that is above the rainfall, the data is actually still quite useful, especially for aviation purposes, especially in the top of the troposphere, tropopause area, and then even the stratosphere. So looking at the NUCAPS profiles for temperature data is still quite useful. You also notice when you're looking at the SKU-T plots of the NUCAPS profiles that the profiles look quite a bit more smooth compared to what you're going to see in your actual balloon RAOB soundings. And that's just the nature of the microwave and IR retrievals. We're looking at 6 to 10 layers of temperature that are resolved in the troposphere and just a few less layers of moisture resolved. So keep in mind, these NUCAPS profiles will be quite a bit more smooth, but the trends are largely pretty well preserved. So where can you find NUCAPS data? Well, first of all, we'll cover up on the AWIPS. NUCAPS is satellite-based data, so you can find that on your D2D windows underneath satellite. At least for here on Guam, we're going to see that under SNPP NOAA 20. And then just through the stair-step menu navigation, you're going to see the gridded NUCAPS at the very bottom. If you look just in that second drop-down menu, third from the bottom, NUCAPS sounding availability, that is where you're going to find the plots for the NUCAPS profiles. That's going to be the green, yellow, red dots that spray across your map view, depending on what the path of the satellite is. But otherwise, you can find all the data in roughly the same location on wherever your AWIPS station is in the CWA. This is an image that I grabbed from the hazardous weather test bed training this past, actually spring of 2021. And so you see the long path that goes from the far southeast to the far northwest, at least if you ignore the curvature of the Earth. That would be the NOAA 20 pass. And then there's a couple of smaller segments over the northwestern US and Canada. I believe those are from the METOP A and B series. So we do get some NUCAPS data from the sounders on the METOP series, but keep in mind the METOP A was recently decommissioned. So now we're left with the METOP B. So that is available for the US, and actually having several satellites providing NUCAPS data can be very useful for stateside operations, especially when you're looking for changes in patterns and changes in conditions for potential severe weather outbreaks, when you're looking for those gradient changes and just the changes in the convective atmosphere. Now, talking about gridded NUCAPS, this is from the NASA Sport webpage. I've got the URL at the top, but also that QR code if you have your phones handy. I hope that works for you. Just stick your phone over the QR code and it should send your phone web browser to this page. This is a page that was recently created, at least the Guam domain, last year, 2021, and especially working with the folks at the NASA Sport who put this together. They've been very extremely helpful in creating the Guam domain for us. There's a couple of domains. You can find it underneath the drop-down menu for the date time. But you're going to see other domains for different regions of the world and the continental United States. The gridded NUCAPS is very nice. You can see all the different parameters in the far left side of the screen. Layer moisture, humidity, temperature, and I really have found that I enjoy looking at this, especially part of my daily operations, and I'll go into some more detail later on. But just as we head into our case studies, this is the Guam area of responsibility. So all those yellow labels, keep in mind, this region is about the size of the continental US. So we're practically all Pacific Ocean and just a lot of small islands with very limited data. So the yellow labels indicate upper air soundings, and the green, Saipan, Guam, and Kwajalein is where we have some form of automated surface observations. We have other surface observations throughout the region, but not very many. So keeping this in mind, the NUCAPS profiles that are offered through 2 to 3 passes every 12 hours is a significant boost to our data assessment and really educating ourselves in the condition of the atmosphere for our operational needs. So with that said, I'm going to hand over to Nick Slaughter, one of our forecasters, to talk about some operations, at least concerning fair weather and with gridded NUCAPS. So go ahead, Nick.
All right, well, good afternoon or good morning to you, depending on your time zone. So a little bit of the climate background, talking about fair weather forecasting. This case study is from our dry season, which runs from about January to July. And as you can see from here, we have 2 different passes, about an hour and a half spaced. But right now we're looking at around 2 meters, the lowest moisture level that NUCAPS provides. And as we can all know, that the ocean tends to be pretty moist overall. But if we go to the next slide, next slide, please. As we start to move up in the atmosphere, now we're looking at around 850 millibars. We can see what makes it up a little too far, but that's all right. You can see this sharp gradient right around 5 to 6 north. Well, that's the trade winds pushing in a lot of dry air into the region. So with this forecasting challenge, as the area I circled, this sharp gradient in the relative humidity helps us focus our forecast and really helps us zone in on the areas where we expect our largest problems. So in this case, Ponape and Kosarai have most of the moisture not only near them, but also on the upstream portion. So we are in the near the equator, so where winds are moving from the east to west in this case. So we're going to be seeing the large bulk of the dry air move into the Marianas, and then the moisture continuing to move into Ponape and Kosarai. So next slide, please.
A little bit of a lag, sorry.
No worries. But yeah, NUCAPS really does help us fill in the gaps with data. There's really no upstream stations for Ponape and Kosarai except the Marshall Islands, or Majuro, excuse me, and they're a little farther north than them as well. So Majuro was sitting well into this dry area. So looking at their sounding, you would have thought that the whole region would be expecting really no rain. But at 700 millibar level, you can see they're right on the edge of that dry air mass, and so they're still unstable. So in this case, looking at this forecast problem, we jumped up the chance of showers and the pops for Ponape and Kosarai, and also started communicating the probability for heavier rainfall. And now looking at the 500 millibar level, this deep moisture is still sitting over Ponape and Kosarai. And you can see north of them, the entire region is basically completely dry, especially the Marianas. Those very clear areas. But this deep moisture bullseye continues from the surface all the way to about 500 millibars. And once again, we started highlighting the possibility for heavier showers. And next slide, please. And then looking at the 300 millibar level, we can still see some of the basically moist RH levels. And this 300 millibar level, especially at Kosarai, is really useful since Kosarai is not an upper air site. We don't have anything to judge it by. And even Ponape, which is an upper air site, these NUCAPS help us see how the trends are changing and how the atmosphere is looking to look like it will change later on in the day. And then this insert, you can see that we had basically a really nice MCS set up over the area, and they got about, Kosarai got about 4.69 inches of rain. Ponape not quite as much, but still around 2 inches. So lots of heavy rain for the region, and because of the NUCAP soundings, we're able to actually see the upstream moisture profile and get the forecast updated in time for the islands to be aware that their weather is going to be changing.
All right, well, thank you, Nick. And just to let everybody know that Nick and I, we're in different parts of Guam, so there is a little bit of lag with our internet. But so I'm going to go ahead and go into a wet season pattern. And so Nick had mentioned January through July being roughly our dry season. Around June, July, depending on the ENSO pattern, June, July, we start seeing some eventual transitioning changes into the wet season. And ultimately, the difference between the dry and the wet season is a large-scale breakdown in the trade wind pattern. So right now, mid-January, we're kind of in the midst of pretty strong trade wind flow, and but that's not always the case in the summer months. And so we see the higher susceptibility for certain mesoscale convective systems, and then also the tropical upper tropospheric trough, especially between 15-20 degrees latitude and farther north. And so we're going to dissect one of those patterns that developed last July. And so right now we're looking at Wake Island. This is the Wake Island is near, truly in the middle of the Pacific Ocean. It's not much in the region. Looking at the infrared satellite imagery, there's not a whole lot worth speaking of. There's a little bit of kind of banded low mid-level cloud cover. You can see some cirrus, but with just a static image, it's hard to tell what's going on. Maybe a little bit of deep convection starting to pop up well to the northwest. But let's take a look at the water vapor imagery. And so a couple of things stand out. First, I've got the 250 millibar streamlines. you can see this general trough axis that it kind of arcs across the north of Wake Island. You see all this dry air funneling around and then kind of sweeping by Wake Island. But a couple other things to note is some areas of higher vorticity, some spinning, and especially this little shortwave trough in here, and then another area of maximum turning. So we're seeing the dominant pattern of an upper level trough, and then several upper level lows embedded within that trough. So how does that look in the gridded NUCAPS fields? So first of all, I want to give you a comparison to the current pattern, just as something to compare with. So on the left side, we're looking at the 300 millibar temperatures. And so there's not a whole lot of change from the deep tropics between the equator, 10 north, 20 north Wake Island. There's just not much change. Looking at the geopotential heights at a 300 millibar layer, again, not a whole lot of change. And this is the typical for the trade wind season. Right now, if we were to look at the upper level pattern, we've got a very large anticyclonic flow centered along 15 north, subsident, very dry air aloft. And that's all the way up to 30 degrees north latitude, so to the north of the scope of these graphics. But let's see what things look like back in July of 2021. There you can see there's a bit of a texture change in the 300 millibar temperature. So roughly there's a 6 to 10 degrees Celsius drop in the temperature by the time you get up to Wake Island. So you can see just the nature of this large cold pool induced by that upper level low. There's a little bit of warmer temperatures. That's where you got a little bit of convection starting to pop up there. But even looking at the 300 millibar heights, you can see probably about a 200 to 400 meter drop in that pressure height between the deep tropics and Wake Island. And sometimes in the tropics, it's just a very minute change that is needed to really result in a very different weather outbreak. So moving forward, let's take a look at the data quality. So here we've got green across much of the board. That indicates good IR and good microwave retrievals. There's some patchy low-level clouds that kind of interfered with some of the IR retrievals. But largely these profiles and the data is still quite reliable. And then a couple areas of red down in deep Micronesia, and then in the far north where there was some precipitation occurring. And I've got this little note down here. This is before the NASA Sport folks had actually added on the latitude, longitude lines, and then the island names. So this back in July 2021 was when the Guam domain was still kind of under construction, and so they've been great and taking our requests and implementing them. So thank you, folks at NASA Sport. So that's your retrievals. And so let's go ahead and dissect this event. So one of the things I like to look at is the different lapse rates by layer. So we're going to look at the lower levels. I just kind of come up with this little y-axis on the left side, just kind of indicate what layer we're looking at. Near Wake Island, there's not a whole lot of change. Maybe some increased stability with the shallower lapse rates, which typical of a drier trade wind pattern. But as we start heading into the mid levels, we start seeing a little bit of change, some steepening of the lapse rates, or we're changing from 5 to 6 degrees Celsius per kilometer. We're starting to approach 7, maybe 8 degrees Celsius per kilometer in the mid levels. And so we see that trend to the southwest, to the west, and northwest of Wake Island. And then as we look at the very deep layer, 850 to 300 millibars, we see that higher lapse rates to the west and the northwest of Wake Island. So perhaps we got a little bit more priming towards some type of convective outbreak. And many times in the tropics, we have very favorable indices for convective outbreaks, but we just don't see anything happen. And it's just a matter of getting the low-level forcing, some type of convective trigger, and then to really take advantage of the potential in the mid and upper level layers, and then we can see some really impressive displays of weather. So let's take a look at the precipitable water. So I've kind of arranged this with the higher atmosphere in the top and then the lower atmosphere in the bottom. Stands out, you see this little smiley face. This is that dry air that we noted in the water vapor imagery. This is seen all the way down to 700 millibar level. So this is very deep channel of dry air through the atmosphere. But once we get below 700 millibars, it's largely obscured by just the typical low-level tropical moisture. But we do see that pickup in moisture to the west and northwest of Wake Island. So again, you see the evidence of that deep upper level feature all the way down to the 700 millibars. Not so much change in the lower levels. Keep in mind, when we're trying to assess convective outbreaks across the tropics, sometimes this could favor some stronger, gustier outflows. Typically in the tropics, when we have some heavy showers develop or even a thunderstorm, we get this small cold pool and outflow gust that emanates from the shower and thunderstorms. But maybe sometimes when we see this drier mid-level air, that could set us up for the potential for stronger gusts. And for across the Micronesian islands, there is a higher vulnerability to such stronger wind gusts. So it's something that we have to keep in mind and continually assess. Let's look at the relative humidity at different pressure levels: 300 millibars, 500, 700. A smiley face of dry air wedging its way from the west toward Wake Island. That is evident in all three. So there's not a whole lot of new information, but we're corroborating these PWATs that we saw just a slide before. And so what happened? I've got 4 satellite loops up here. You can see the 1-minute lightning data on the top right, the IR, the visible in the bottom right, and the water vapor. What you'll notice is there is generally more of an easterly trade wind flow at the surface, and then you see those the stronger westerly winds aloft on the south side of that upper level trough. But what happened was we saw the development of an MCS that backed several hundred miles to the southeast against the low level flow. This thing lasted all day. It lasted for about 24 hours, and you can see just in the daytime loop of the visible that it continued to develop, producing quite impressive lightning. There's a lot of booming going on, and Wake Island is known for seeing some of the impressive thunderstorms based just related to the upper level patterns. And so this was one of those interesting ones. You can see in the visible this outflow gust that really zipped out to the west. And so what happened? It looks like we had really good favorable upper level features. We were primed convectively, and then there was just a little bit of enough of a push in the trade winds, perhaps a passing surface trough. You get enough convection going, and then you're able to take advantage of the upper level patterns. And so we saw this erupt near Wake Island. Granted, this is not a location that we provide forecast for, but it's my opinion that we should be looking for these types of patterns where we could possibly beat the models. The models don't do very well in the tropics forecasting such inclement weather patterns, and so it's up to us to look across the region to get familiar with these patterns that combine and what causes things to erupt, so that we are ready to forecast these events should they line up closer to our forecast points of interest. So we're going to move forward, and let's go ahead and look at a dry season pattern. So we're looking at the rain showers, and then do we put thunderstorms or not in the forecast? So we're going to be looking at some dry season patterns, especially one that we're kind of seeing over the Marianas right now. But if you're an astute observer of these next several slides, you're going to see that perhaps some of these shear lines don't quite line up in the same place, slide to slide. It's actually an accumulation of different shear line events that I had accumulated a lot of the imagery to use for this case study. But what are we talking about, a shear line? Shear line is just this region of cloudiness across the Marianas it's the southern extent of a cold front. The cold fronts zip across from Japan and the Chinese coast, and they zip eastward across the northern Pacific, and the very far southern extent is what we call a shear line. And so, like I said earlier, January through May is when we see these shear line features, usually a periodicity of 5 to 10 days. It can be a little bit shorter, it can be a little bit longer depending on the pattern and really how far south these cold fronts pass from Japan and Taiwan. With the shear lines, the higher res models, the ARW, the WRF, they tend to go a little overboard with precip estimates. Sometimes we see 4 to 8 inches per day with these shear line features, and we would rarely ever put that type of a QPF with a shear line. There are some conditions that could lead to that, but largely not the case, and I'll show you more shortly. Similarly, we're looking at the national blend models, the oceanic version. We do have 12-hour probability of thunder, and sometimes it does show highlighted risk of thunderstorms with the shear lines, but is that realistic or not? And so what do we expect in these situations? So here's the NUCAPS that I've added on. You can see the surface stream lines indicated in the kind of tan shaded lines. And so you'll see the patchy low-level clouds. There's a couple of yellow profiles. That's where there was enough cloud cover that kind of it deteriorated the IR retrievals, but still the microwave retrievals were good. Pop-up QT for that area to the northwest of Wake Island, very dry areas and moisture is capped in the very low levels. So this is typical of the shear lines and not very favorable for thunderstorms. And now as we head closer to the Marianas, this first pop-up QT, you can see a slightly deeper moist layer. Cloud top might be a little bit too high, and that could be related to maybe a little bit of a distortion of the cloud top temperature as this thin cirrus is kind of lofting over the low-level clouds. But the pop-up QT to the northeast of the Marianas looks quite a bit more classic to the shear line. Very low-level moisture, low cloud tops below 10,000 feet in general. So let's look at the lapse rates, 7 to 500 millibars, roughly 10 to 18,000 feet. There's not much change in the lapse rates, but as we start getting lower in the atmosphere, 850 to 700 millibars, we start noticing the difference in stability. We have high pressure ridge farther to the north of the Marianas, and then we start seeing that tropical instability, which is just kind of ever present across Micronesia. But finally, in the low levels, below 4,000 feet or so, we definitely see the effects of the shear line and that increased mixing, that convective instability. Very shallow though. How about the difference in the SCUTs? On the top right, that is the NUCAPS profile nearest to Guam, and then one of the recent Guam RAOBs. You'll note there's a little bit of a change. I grabbed the wrong RAOB. I should have grabbed the 12Z for closer apples to apple comparison. But you see the very deep layer drying, and you also see the trade wind notch, that little inversion above the moist layer. Not quite as readily apparent, but that could also be related to the time of day, 15Z, which is 1 a.m. local, versus the 10 a.m. local RAOB. The features are largely preserved, and you can see that very dry layer. So it's definitely more notable in the actual balloon sounding, but ultimately you can still make out the same features. And sometimes we see very close precipitable waters between the Guam sounding and also the NUCAPS profiles. You'll notice in all these images that I have overlaid the soundings, the NUCAPS soundings. It's either, in this case, I've got the satellite imagery, but I would highly recommend setting up a procedure where you have either satellite imagery or some type of precipitable water. I like to use a mimic TPW, and that way you've got a context of the background, and that kind of informs you what you should be expecting to see in the NUCAPS data. So let's look at the layer precip water. 7 to 500 millibars, 10 to 18,000 feet. You see a very dry air over the Marianas. So that boundary, that gradient has passed to the south of the Marianas. Very dry air, typical. We should expect that with the profiles. As we head lower to 850 to 700 millibars, roughly up at 10,000 feet, we start seeing a little bit of indication of that shear line moisture. coming across. There's a difference. There's a little bit more moisture, 700 to 500 millibars farther north. That's actually some moisture lofting up from deep convection farther to the southwest. It's just kind of streaming up, and it's farther north of the shear line. And then finally, in the very shallowest layer, we definitely see the effects of the moisture with that shear line and the surface to 850 millibars, roughly the lower 4,000 feet. And then when we look at the relative humidities, not much change to what we should expect looking at the PWatts. You see at 700 millibars, no real sign of the shear line. It's all below 700 millibars. This is a very shallow feature and would not expect to see thunderstorms. So what should we expect? Definitely showery conditions, but perhaps nothing accumulating beyond 1 to 2 inches in a 24-hour period. And sure enough, in this past week, we've had the shear line kind of parked over the Marianas. We've seen up about 4 inches in the past 6 to 7 days. So for dry season, this has been a very appreciated wet pattern for the dry season, and it has really eased our short-term fire concerns. Now, we do see the higher rainfall amounts where the shear line sits overhead, with the showers training from the northeast to southwest, but ultimately no thunderstorms. And if you were to look at the different forecasts provided by different services and businesses or whatever in the media, there were thunderstorms in a forecast in the newspaper. And so the newspapers get their sources of forecasts from internet provider. And but we had no thunderstorms in our forecast, and ultimately no thunderstorms developed. We had showery conditions, but no thunderstorms. So this helped, it provides that verification to support the model data, and really we should be bridging all these different data sources, satellite model, various satellite data, to make a very well-informed forecast. So as I wrap it up, I just want to give a plug to the CIMSS satellite blog. If you have not bookmarked this page, I highly recommend it. They've got a lot of NUCAPS articles. They've got a lot of articles, the recent Tonga volcanic eruption. There's a lot of good satellite imagery in there. But I look at this bookmark every day, every shift, because I like to see what they're talking about, and if there's another tool that I could use in my operational assessments. So there's a QR code if you want to use that for your phones. And of course, this webpage, this presentation will be saved for your later usage. And then finally, Scott Lindstrom, he's got some training provided through the RAMB Sierra webpage, but also in the CLC, you can find some NUCAPS discussions, just some general backgrounds. And so I would recommend, as you make your procedures, the best way to do it is make a procedure and look at different things, and over time you're going to find something that works for you, and you'll get familiar with implementing these new tools to have them for your forecasting enjoyment. And so finally, I want to give a big shout out and thank you to Scott Lindstrom and all the others at CIMSS, Chris White, Emily Burnt over at NASA Sport. I work with them for the hazardous weather test bid. I have worked intensively with Chris with the NASA Sport, just giving suggestions for making it more user-friendly, especially out here. And then Bill Schoberg, just for the past several years, these folks are very helpful and are very eager to discuss things and find out how we use it operationally. And so with that, I'll go ahead and close it off, and I'm free to take any questions. So Scott, hand it back to you.
Thanks, Brandon. Always happy to hear about the tropical Pacific when I'm looking out the window at snow on the ground. I guess I have a question, and
Okay.
you can get gridded NUCAPS in AWIPS.
Yes.
But the gridded NUCAPS that you were showing, I think were all from the NASA Sports site.
Correct.
So is that do you have the NASA Sports site like in a situational display setting, so you go in and just kind of glance at it to see what's happening that day, or is this something you're doing on shift at your AWIPS terminal with another window open to look at gridded NUCAPS instead of looking at them within your AWIPS?
Good question. So we have our administrative PCs right next to our AWIPS workstation, And I find it, at least for me, it's easier or more reliable to have the NASA Sport pulled up on the internet PC. Sometimes we do have some internet issues. The data feed for the gridded NUCAPS on AWIPS is sometimes interrupted. So where you see a continual pass across the Marianas and the image displayed right now, sometimes we see just little blips of data that is interrupted with the data feed. And so it's not always reliable. So that's why I tend to gravitate for the NASA Sport page. And with that said, the NASA Sport page, at least for the Guam domain, we've got data that goes all the way back to last spring. So we can actually go back and dissect past events pretty easily.
Okay, thanks. That's good to know. And we had one comment on the Tom Clemens, who I think is a Sioux in, I think, Glasgow, said that the the dry air that was in Nick's slaughters looked really a lot like a central U.S. dry line.
Yeah. and yeah, so that's a really good thought. During the hazardous weather test bed, we saw those dry line gradients, and you can really peg it to where the convective initiation picks up on, and so it's something that during the hazardous weather test bed, being introduced to the data that's now available at our fingertips, it's a steep learning curve, and so that's why I recommend it. I know, Scott, you mentioned it in some of your training, that you go ahead and make the procedures, look at the stuff on the non-busy days, get familiar with it, and that way you get a feel for it. And then when weather starts popping, you know what you're looking for, you're comfortable with it, and you know where to look for that information to kind of fill in the blanks.
Okay, I see another question from David Hitzel.
Okay.
In Nick's portion, he shows an image of the NUCAPS 2 meter relative humidity.
Yep.
Can this product be used to confirm recent precipitation over remote islands where there are no observations? Say if the 2 meter relative humidity registers as 80 to 90%, can you just kind of assume that it's rain there? Would it be useful to confirm where it's actually raining under all those anvils in the IR? Well, I'm going to answer that last one.
Okay.
If you have anvils in the IR, you're probably not going to see useful information at the surface. I'm not sure. I'll let you answer the one about it. Can you use the information at 2 meters to infer that precipitation will happen if you have 80 to 90% relative humidity?
That is a good question, and I'm not fully sure because it depends on the ability of the satellite to really effectively sample that deep into the atmosphere. And so if you're talking very recent rains, there may still be some effects of lingering cloud cover. I know at the tropical convection, you have these very heavy convective downpours, and then after it has ceased raining, you've still got this stratification, stabilization that is still obscured by mid and upper level cloudiness. And that may actually prevent some of the NUCAPS retrievals. So I'm not sure how reliable it would be compared to perhaps some other microwave imagery.
Can I add one other thing too?
Yeah, absolutely.
I don't know too much about the recent precipitation. I'm not sure about that, but looking at the individual NUCAP soundings, especially when they're near the surface, I use them a lot of times to get the ceiling for TAFs. It's helpful when looking at the lowest layers to see where the LCL is, especially for Guam being a 30-hour site, looking at how the air mass changes moving into the islands. That's kind of one of the biggest uses for the low-level humidity for me.
That's interesting for me to hear because I know a frequent observation made about NUCAPS over CONUS is that the surface values don't really match what's going on at the surface. So it might be too dry. The NUCAPS might be too dry or too cool or something like that. And I'm just wondering if it's the character of your underlying surface over the tropical Pacific doesn't really change a whole lot. So it makes the lower part of the NUCAPS sounding in your part of the world a little bit more reliable. I'll have to ask, we have a telecon coming up at the end of the week on this. I'll have to ask about that.
Yeah, and I guess similar, comparing a local RAOB sounding with the nearest in time and location NUCAPS profile and the mimic TPW. Sometimes we see a little bit of disagreement in the moisture content, but sometimes the three of them are very close, and I'm just curious on the nature of that. And so I'll eventually find another case, and I'll send you the comparison, you and Bill as well.
Great. We have one last comment, I guess, because we're running kind of late. Jarell Torres from Sierra notes that there is an ALPW advected layer precipitable water product that separates precipitable water into layers similar to what you're looking at in NUCAPS, the gridded NUCAPS from the sports site. So it might be useful. It might be useful to look at that to compare things versus the entire layer that you get from Mimic.
Exactly.
So
is that available for the Western Pacific? I know there's some stuff that's created for the CONUS.
I believe it is now global, and he has a link here that I'll grab and send to you.
That would be fantastic.
Does anyone have any other questions for Brandon? If not, I will say thank you. It was great to hear from you. Great to see how NUCAPS are being used out there, and I'm glad there are other people who are evangelizing NUCAPS. So that our next FTDT webinar, by the way, will be given by a Guam alumni. Derek Williams will be talking on February 2nd about his IMET work with the fires in the Western U.S. So look for an email about that. Thanks again, Brandon.
Thank you, Scott. Take care.
Yeah, thank you.